Hey pre-calc, I, as promised, am showing you the rest of the notes for 3.3? So, like I said, you guys might want to do this on a separate piece of paper because it's a lot more writing than probably you have room on the actual notes document. So, let's get to it. I'm going to do number 5 over again, even though I really talked about it already in class. It's not an issue. So, this little notation here means g of f of x. In fact, I'll make the g red and the f of x black. So g of f of x versus f of g of x. So when you think about what g of x is, if you scroll back up to the top page with the examples, you guys will have to look up this on your own. I'm not going to scroll up and down throughout the video. So g represents x over 1 minus 2x, right? So it's basically just saying, in place of the x, we want you to put f of x. That's all it's saying to do. So I'm replacing the x with f of x. Replacing the x with f of x. That's what function composition is. It's a function composed of another function in place of its variables. So now, f of x is equal to 4x squared minus 4x plus 5. This is the numerator. That's literally what f of x equals. In the denominator, you get 1 minus 2 times that same polynomial. Now the new function I'll put in blue. So g of f of x. If I do some algebra simplification on the bottom, it's going to turn out to be negative 8x squared plus 8x minus 9. I skipped a few steps there, but since I showed you in class, I don't think it's a big deal. The top is going to be 4x squared minus 4x plus 5. This is my new function. So when talking about the domain of this function, you want to be very sensitive to the input function. So I'm going to put that over here. Hey. So the domain. First thing you're going to do is you're going to say, what was the domain of the input function? What was the domain of the input function? Which is the function that's inside the parentheses. It's the one that you put into the other function. All right? So f of x is the input function. Well, it's a polynomial. There are no domain issues. F of x has no domain issues. So it's kind of like f of x is bringing no issues into this relationship, okay? There's no domain issues. So as far as we're concerned, whatever the domain is, it's the domain of the final result. Okay? So you got a fraction, you set the bottom not equal to 0. So this is kind of like step 1. Step 2, just determine what our new function would be. How about g of f of x? Any domain issues there? Well, wherever the bottom equals 0, that's a domain issue. So we want it to not be 0. We got to use the quadratic formula to compute all this because this is not a factorable polynomial. You get negative 8 plus or minus 8 squared minus 4 times negative 8 times negative 9. And then divided by 2 times negative 8. So just to double check what was computed in class, 8 squared minus 4 times negative 8 times negative 9. indeed is negative 224. So x equals negative 8 plus or minus root negative 224 all over negative 16. How well can you guys see that from here? I think you can see it. So that negative completely eliminates any real solutions that we might have. There's no real solutions. There's some imaginary ones, but we're not concerned with imaginary solutions in this chapter. So there's no solution to the equation equaling 0. So, where does this equal 0? It doesn't. So it doesn't not equal 0. I think I said that all messed up. Bottom line is, the bottom can't be 0. And if the bottom can't be 0, that means there's no divide by 0 error. No domain issues. So, our final answer for the domain, suffice it to say, is all reals, negative infinity to infinity. Great. So then check out f of g of x. That would be this part right here. Yeah, I'm looking at f of x, and that function is 4x squared minus 4x plus 5. But in place of the x, I'm putting the entire function g of x. So it's really 4 times the function g of x squared minus 4 times g of x plus 5. So I'm squaring this entire function, x over 1 minus 2x. So, yeah. 4 times x over 1 minus 2x squared, all right, minus 4 times x over 1 minus 2x, and then you add 5 on the end of that. Wow, so there's a lot going on here, right? Now, here's what I want to do with you guys. I want to keep in mind that the new function we have really only has domain issues in the denominator, okay? So just looking ahead, we really can do some shortcuts here when we determine this function. So the blue function, our final result, I'm just going to write as this square can just attach itself to both the top and the bottom independently, okay? So this is x squared over 1 minus 2x squared. All I did was say square the top, square the bottom. Now, when you multiply that by 4, that's the same as multiplying by 4 over 1, which means the numerator gets the 4. And then you're going to see the exact same thing happen here, except we're not even squaring anything. It's just going to be minus 4x on top over 1 minus 2x on the bottom. And then plus 5. So you don't need to do any more simplification beyond that. That is your f of g of x function that they're asking for. Now the domain on this one is trickier. Okay? Let's go off to the side here and talk domain. On this function for domain, step 1, input functions domain. Your bottom can't be 0. So, what you plugged in instantly carried with it that 1 minus 2x could not equal 0. it ends up being x can't be 1/2. So you're keeping in mind this entire time that no matter what the domain of the new function is, x cannot be 1/2. Just can't do it. Now, it really didn't make a difference because when you look at these two, they're both the same domain issue that you had for your input function. So, for this, it's sort of like saying, hey, all I got are fractions. The fractions are the problems. 1 minus 2x can't be 0. We already know that. That's not giving us anything new. And 1 minus 2x squared can't be 0. But here's the thing. Square root both sides, it's 1 minus 2x can't be 0 again. So there's no new domain issue based on what we get from our composite function. For a final answer, it's still x can't be 1/2. Every other number's okay. So our final answer for the domain, if you want to put it in interval notation, it's -infinity to 1/2. You put parentheses because it's on the bottom of a fraction. And then 1/2 to infinity. All right. Wow. So, I kind of want to just stop the video there and say, you've been introduced to function composition, okay? And then I'll do the next few examples on a new video. Thanks for watching.